Hi, my name is Henry Lee, and for the week 6 video, I'm gonna cover supervised fine-tuning. I'm gonna base my slides on the video made by YouTuber Andrew Karpati, titled "Deep Dive into LLMs like ChatGPT." To recap, an LLM, or a large language model, it's an artificial intelligence that has been fed a large amount of text to the point it can generate responses to the user's prompts. And most LLMs use a transformer, which breaks the input text into tokens and predicts what comes next in the passage based on those tokens. So the prompts or the input is the text that we give it to the LM, and based from the input text or those prompts, it's gonna respond to it. So whatever question we ask, it will um, it will break the questions into tokens, or the words or the parts of the question into tokens, and it will individually calculate the values of those tokens, and then like predicts what comes next based on those values. As you can see here, like the input text is split into pieces and tokens, which they're not necessarily whole words. It could also be punctuation or like parts of words, and then like it is assigned like a vector column of values that represent their meaning. And once we do this, we get a base model that it is able to take user's input or like a user prompt, and it will generate text based on that prompt. And the way they do this is by looking at the table, at the values of the tokens, and generating a probability distribution of all the words that is likely to come next in the sentence, so that it could generate a response. But the problem with this is that it's too simple. We have to refine it more so that it is more efficient and it is more complex, or it could take more complex prompts. So after the pre-training, we move to the post-training. And we turn a model that regurgitates words from memory into an assistant that understands tasks. What I mean by this is that this model is too simple. If you tell it to do like a complex task that is not in here, because it has no values, it won't be able to produce responses because they don't understand. They don't have that information to predict or to generate the response. So we so when we turn it into the assistant, it it will be able to generate responses even if it doesn't know the the topics of the words, or like if the task is too complicated, it will still be able to generate something. So the way to do this, we repeat the training stage by using conversations instead of text. As you see to the left, the conversations are exactly what it sounds like a conversation of two people, and the user and the assistant. What is 2 plus 2? 2 plus 2 is equal 4. And the way this works is like the conversation is turned into tokens again, like here, because it doesn't the LLM doesn't understand words. You have to split them into tokens, and those tokens have values in the form of vector columns. So same process here. We split the conversation into tokens. As you can see, what is 2 plus 2 question mark, and the different colors here represent different tokens. You may also notice that in addition to the tokens that we provide, there's also other special tokens like I'm star and I'm n, which signifies the end at the start of the sentence and the end of the sentence. You can also see another special token called user, and another one called assistant, which I'm guessing like is to specify who's saying what. And these conversations are provided by human beings. Like human laborers provide the ideal response in any situation. So they these are professionals. They write this like professionally, and they're paid to do this. And they just don't write anything. Like they have to be a very specific format and very specific answers, good answers. And and this is so that the AI can imitate them. If we provide a lot of conversations, and the AI it will be able to repeat the process, or like to follow this process, this format, and to able to generate his own conversations. And you may ask, what is the ideal response? Well, the ideal response uh, is provided by the company that hires those workers. What do the company look in specific? For example, truthfulness and helpfulness, or like not harmless stuff. You can also define the the parameter basically, so that the laborers or the workers, the professional writers, can provide ideal responses based uh, on the characteristic that the company is looking for. And that is that's one way to program the AI to get like specific responses, or like to answer in a specific ways basically. So what happens when you ask a base model a complicated task or information that it doesn't have in memory? Well, you will create hallucinations. Hallucinations occur when there is no pre-trained response. The model won't tell you that it doesn't know, so it will just give you a bunch of nonsense. As you can see here, it looks at the table of values, and it would predict what comes next using like a probability distribution. And this means that it will always be producing something from the probability distribution. And it doesn't matter if it's right or wrong, it just has to generate something. So an hallucination is just like a bunch of nonsense. If it doesn't know something, the LLM will just make it up. But like assistants are different because they understand tasks. And the way you understand tasks, or like there's two ways so that the assistant can understand how to like combat hallucination. The first form of mitigation is to teach it to say, I don't know, add conversation that result in refusal. So like here right now, if you keep adding like conversations that like end in refusal, or like that, so that the assistant replies, I don't know, I don't have enough information to answer. If you feed them a lot of these um, conversations, at some point it will um, that the LM will connect like a certain level of uncertainty from the questions and match it up with the I don't know answer. So, for example, if you asking like a super duper complicated task, and you ask them for the assistant, you said I don't know, it will try to emulate this behavior. So whenever it sees like questions that have like a super high uncertainty value, it will answer I don't know. And the second way that assistants can mitigate hallucinations is by allowing the model to search through the web. As we learned before, the assistants have like special tokens that manage the conversation, like I'm star or I'm in. Well, there's also like other special tokens like search star and search n. That if the answer you put search n and search star and search n, for one of the questions and for the answers, it will basically open like a new session and it will research the web and it would return all the information they can and would produce a response based on the information that the AI obtained from the web, from searching the web. Another important thing that we need to know about is context windows. As you can see here, context window is a terminal where we interact with the AI, where we can talk to it directly. And the AI is able to access information from the context window. So you could add it like attach it to a PDF file or like other type of files, and it can read it. Once there, it is easily accessible to the AI. So any information that you provide, any information they provide here, the AI will see it and it will even use it to generate responses. So if you're looking for a specific niche topic that it doesn't have in the memory, you could just give it to it and it would generate responses from the information that you give it. And this basically creates the identity of the AI. And because it's like you're personalizing it or making it unique to the conversation, to you, with you. Because when the session ends or it closes, the AI is resets. No knowledge is retained or saved. It resets to blank. If you ask him about Spider-Man, it, it won't be able to remember about Spider-Man, nor remember that you talked to him. It will be as if you were talking to like a different person. Because context window is basically the brain. It gives the memories of the interactions with you. And I also wanted to talk about bad conversations, or like what are bad examples of conversations. As you can see here, we're providing it with the AI with a question or like a mental problem. And it generates two different responses, but like they're both correct. The only issue is that like one of them is bad, is a bad conversation. You should not just use it to train the model. And it is the one to the left. If you train the model to answer directly and immediately, it will cram all the calculations in a few tokens. As you can see, it only has like five tokens, and it already done all the computation calculations here in just five tokens. And the answer is right here, but like if it was like a complicated problem, it would give like a wrong answer because tokens can only handle small calculations, so it would struggle with complex tasks. It worked here because the problem was simple enough, so it was able to answer it in few problems. But if the problem, or if the LLM is trained to use a few tokens for like large problems, it will create wrong results because it is not able to complete or calculate everything with a small number of tokens. It is better to split the computation into parts called intermediate results. As you can see here, it first splits all the calculation into the prices of the oranges, which calculate 4. And from the 4, it calculates the prices of the apples. So it's doing a token, spread out the calculation throughout all these different tokens, or like all these tokens. And it finally gets the answer here. But like at that point, it already used the calculations in all of the tokens. As opposed to this, where like it already generated the calculation from the start, all the calculations from the start in a few tokens, versus this where like it has the computation spread across all the tokens.